Hello everyone and welcome to another episode on the Vlog channel. In today's lesson, we want to look at this particular example on the board. Only this particular example on the board. It looks very beautiful and cute, right? But it involves a lot. It involves a lot. So we are going to look at only this particular example and then we see how best we can solve it. Remember that this example on the board falls under semi-linear PDE, and we said that for a PDE to become a semi-linear PDE, then the non-linearity must be on the dependent variable u. So you can see that what makes this PDE non-linear is on the dependent variable u. So this is a semi-linear PDE, and we want to solve it using the method of what? Characteristics equation. So without wasting my time, let's set the ball rolling. So in using the method of characteristics, the first thing that we have to do is to identify our A, our B, and our F from the equation given or from the question given. So from the equation, our A is the coefficient of ux, that is 1. Our B is the coefficient of uy, that is what? Xy. And then our F is the equation on the right hand side, that is u squared minus 1. Now once you have this, you write down our characteristics equation, which is giving us and then we have our du all over hot f. So once you have this, we plug in this. So we are going to have dx all over 1 is equal to what? Dy all over what? Xy is equal to du all over u squared minus 1. So we have formed the characteristic equation from the question given. And this characteristic equation has transformed or converted this PDE into an ordinary differential equation, and we can solve it using any of the methods that we know in solving ordinary differential equation. And whenever your f is not equal to 0, we are going to form two equations from the characteristics equation. So let's start with our first equation. So with that, we are going to pair the x and then the y. We are going to take this, and then we get our first solution from this particular part. So we have our first equation. So we are pairing dx is equal to dy all over what? X all over y. Now with this, you can see that we can separate the variables into the x and the dy, but realize that we have an x here. So let's clear this x, or let's eliminate this x by multiplying both sides of the equation by what? X. So we are going to multiply here by x. So we have x times dx is equal to x times dy all over what? X all over y. So from here, you can see that this x will cancel this x. We are left with x. The x is equal to what? Dy all over what? Y. So from here, we can just integrate because we have separated the variables. So we are going to integrate both sides. So we have the integral of x dx is equal to the integral of what? Dy all over what? Y. Now when we integrate x dx, we are going to get what? X squared all over 2. Then we add our constant of integration. Since we are going to have two equation form, let's call this C1. And then when we integrate dy over y, so we can write this as integral of 1 over y dy. When we differentiate y, we are getting 1. So we have a function and a derivative. And that gives us what? Length of that function. So we have length y. Since we are having length, let's take the length on the constant as well so that we can clear the length from the equation. So we have length on the constant y. So we have our x all over 2. Now, since we are looking for c, or we want to make c the subject, let's bring c to the right hand side of the equal sign. So we are going to have length y minus our length c1. So we have x squared all over 2. Applying our basic knowledge in logarithm, we can pick one of the length, and then what do? We divide the argument. So we have y all over what? C1. We want to make C1 the subject, right? So let's take e on both sides of the equal sign so that this e will cancel the length. So we have the e and then that, so that this will cancel this. So at the end, we are left with e exponent s squared all over 2 is equal to y all over c1. We want to make c1 the subject, right? So you can say that our c1 is equal to, this will come down. So we have y all over e exponent s squared all over 2. Now we can write this in an index form, or applying our basic knowledge in indices. We can write it as c1 is equal to y multiplying e exponent negative s squared all over 2. And this becomes our first solution. That is c1 is equal to that. Since we are having 3 equations, we are going to pair the u with any one of them. So we can pair the u with that. We can pair the u with that. And then the one that you are pairing with, it should be easier for you to solve or to work with. You realize that we have an x here, so it is very difficult for us to solve it. So why don't we pick the x and then the u, so that we can apply other methods to solve such equation. So we are pairing the x and then the u. So we have the x is equal to what? The u all over u squared minus 1. So at this point, what we are going to do is integrate both sides. So we are going to integrate that, and then we integrate that. So when we integrate the x, we are going to get x, and then we have equal to. Now when we integrate the u all over u squared minus 1, now we can write this as the integral of 1 all over u squared minus 1 du. So with this, we can't just integrate it straight away, or neither can we split it and integrate it straight away. So what we are going to do is to apply our knowledge in partial fractions to help us integrate this. So I'm going to help you with that. So we are going to have the integral of 1 over u squared minus 1 du. Now we can write this as the integral of 1 all over u minus u plus 1, and then we have u minus 1. Now you can see that this is difference of 2 squares, so we can split it and write it as that. Now applying partial fraction, so let me write it here. Applying, we can write this as 1 all over u squared minus 1 is the same as a all over u plus 1. Then we have plus b all over what? U minus 1. That is applying the partial fraction to help us solve it. Now we want to integrate this. That is why we are going through this process. Now once we find the integral of this, we are just going to add it to this particular place, and then we proceed. So let's continue from this side. So from here, we can say that our 1, this 1 is equal to a multiplying u minus 1, and then b multiplying u plus 1. So we have 1 is equal to a multiplying u minus 1 plus b multiplying u plus 1. So at this point, what we are going to do is to eliminate one of the terms, either this or that. So you can see that at u is equal to negative 1, this is going to be 0, right? So we are going to have 1 is equal to a minus 1 minus 1. And that we are going to have our 1 is equal to what? Minus 2a. So from here we can say that our a is equal to what? 1 all over minus 2 or minus half. Now at u is equal to positive 1, this one will go to 0, so we'll be left with this one. So we have 1 is equal to b, and then we have 1 plus 1, and that is going to give us 1 is equal to what? 2b. So from here we can say that our b is equal to what? 1 all over 2. So we can say that our integral of 1 over u squared minus 1 du is the same as the integral of our a is what? Our a is minus 1 over 2, so we have minus 1 over 2 all over u plus 1, and then we have du plus integral of 1 over 2 our b, and then all over u minus 1, and then we have du minus 1 over 2 integral of 1 over u plus 1 du, and then we have 1 over 2 integral of 1 over u minus 1 du. We are not yet done. Now you can see that when we integrate 1 over u plus 1 du, we have a function and derivative, because when we differentiate u plus 1 with respect to u, we are getting 1. So we have a function of a function and derivative. So this one becomes minus 1 over 2 ln u plus 1. Then we have plus 1 over 2. When we integrate this, we have a function and derivative, so we are going to get ln of what? U minus 1. So this means that the integral of 1 over u squared minus 1 is the whole of this. So this is what we were looking for, the integral of that, and we have seen it. So we are just going to continue from here. So we have x is equal to, minus 1 over 2 ln u plus 1, and then plus 1 over 2 ln u minus 1. Then we add our constant of integration. Since we have a lot of ln inside, let's take the ln on the constant as well. We're having c1 here, so the constant here will be what? c2. So we have our x is equal to 1 over 2, we have ln u minus 1 all over u plus 1. Then we have c2. Since it is adding, so we are going to multiply it. Very, very easy and then simple. So let's multiply through by 2. So we are going to have 2x is equal to what? Ln u minus 1 u plus 1, and then we have c2. We want to make c2 the subject, so let's take the e on either side of the equal sign so that this will cancel this, and we'll be left with what? Let's continue from this side. So let's keep c1 same because we'll be making use of it. We are going to make use of this one. So we are going to be left with e exponent 2x is equal to c2 multiplying u minus 1 u plus 1. Our interest is to make what? c2 the subject. So we can divide both sides by u minus 1 u plus 1, so that this will cancel this, and you'll be left with c2 is equal to e exponent 2x divided by what? U minus 1 u plus 1. I believe you understand what I did here. We are dividing both sides of the equation by u minus 1 u plus 1. So this one will cancel, we'll be left with c2 here, and then we have this divided by that. Good. So we have our c2 is equal to e exponent 2x, and then we have this will go up u plus 1 all over u minus 1. Very, very easy and then simple. So this is our c2, and that is our second solution. So we have C1 and then C2. And whenever you have two solutions or two constants, one becomes a function of the other. So it is either C1 becomes a function of C2 or C2 becomes what, a function of C1. So since we are having U in C2, let's pick C2 becoming a function of what, C1. So C2 we had this, so we have, let's write it, y exponent 2x is 2x u plus 1 all over u minus 1 is equal to a function of C1 we had y exponent negative x squared all over 2. Very, very easy and then simple. Now we can clean our C1. So at this very point, we can leave our answer in this very form, but you can still continue to make u the subject. You can end here if you are really tired. You'll be marked correct. And then if you want to continue, then we have to continue and then make u the subject. Okay, so let's continue and then make u the subject. So let me write it as that. So at this very point, we are just going to play with algebra. We are just going to play with our algebra and then see how best we can solve for u. So from here, if you want to make u the subject, then let's divide both sides by e exponent 2x. So when we do that, you'll be left with what? U plus 1 all over u minus 1 is equal to, we are dividing both sides. So we are dividing both sides, so this will cancel this. We are left with what, that. And then we are dividing, so we have a function of y exponent negative x squared all over 2. And then we have e exponent negative 2x. Indices, it will be like this, e exponent 2x. But we can write it as this negative reciprocal in indices, so we can write it as that. So let's clean this one to make it look more nice and beautiful. So we want to make what? U the subject. So what do we have to do? Let's multiply both sides by this, so that we left with u plus 1. Good. I guess you are following, eh? In fact, I really love this particular question because it will make you think. You will think a lot, and then you can apply your basic algebra. So let's multiply both sides by u minus 1. So when we do that, this will go, right? So let me write it as u plus 1 because we are multiplying both sides by u minus 1. So this will cancel this, and then we have u minus 1. So we have u plus 1 is equal to a function of y exponent negative x squared all over 2 multiplying e exponent negative 2x, and then all of this is multiplying what? U minus 1. So when we expand, we are going to have u plus 1 is equal to this times this will give us u e exponent negative 2x multiplying a function of y e exponent negative x squared over 2, and then we expand this with negative 1, and that's going to give us the whole of that. So we have e exponent negative 2x, and we have a function of y e exponent negative x squared all over 2. Very, very easy and then simple. You want to make what the subject, the u the subject. So this have to come here, and then the u have to go here. I guess you are following. So we are going to have 1 plus e exponent negative 2x, a function of y e exponent negative x squared all over 2. And then this u have to go there. So you have u, this u, e exponent negative 2x, a function of y e exponent all over 2. And then what again? Minus u. Very, very good. So at this point, we can factorize u out. So we have our u is out. We are left with e exponent negative 2x. And then we have a function of all over 2. and this will give us -1, right? So let's use the macro brackets. And this is equal to 1 plus e exponent -2x So let's divide both sides by that, so that we left with what u, because we are interested in what u. So we have our u is equal to e exponent -2x, and then we have a function of y exponent -x squared all over 2, and then plus 1, and then divided by this. So we have e exponent -2x, and then we have a function of y e exponent -x squared all over 2 minus 1. So the general solution to this particular PDE is this one, what we have just finished, this one. So this was the general solution. Very, very easy and then simple. As I said, if you feel that you are tired, you can end at this very point, you will mark right, but you can continue to play with the algebra and end at this very point. See you tomorrow. Bye bye.